Hi everyone, I hope you're okay. And guys, I really hope the videos we keep uploading for both maths and science are helping you out preparing for your final examination. If you're new to the channel, guys, please do not forget to subscribe and do not forget to tell the others to come and join the family with preparing for your final examination, knowing and mastering topics in maths and science. This video, guys, I'll be just doing question 5 from the grade 11 question paper, which was written in the year 2021 in the province of Gauteng. We are still under the topic of chemical aspects of chemical change. Okay, let's get right into it. We are told that sulfur dioxide has a pungent, which is an irritating odor that is similar to the smell of just struck match. Although its chief uses are in preparation of sulfuric acid, sulfur trioxide, and sulfides, sulfur dioxide is also used as a disinfectant, a refrigerant, a reducing agent, a bleach, and a fruit preservative, especially in dried fruits. The balanced equation of the decomposition of sulfurous acid is as follows. Okay, we can see that that the sulfurous acid, which is H2SO3, decomposes to water and sulfur dioxide. Okay, we are told that two samples of sulfurous acid with equal mass of which one is pure and one is impure are placed in open containers, okay, on a balancing scale. Since these, before I even look at the question, I'm told that these are placed on open containers and one of the products which is formed is a gas. That means the gas will be able to escape the reaction vessel or the container. Okay. Okay. The graph below shows the results contained by the graph. The graph below shows the results obtained, and the graph becomes parallel to the x-axis when the reaction is complete. Okay. Once the graph becomes flat, it shows that the decomposition of sulfurous acid has completed. Okay. 5.1, the question says explain why the mass of the flask with its content decreases. Okay, remember that I said they did mention that the containers are open and we are producing sulfur dioxide, which is a gas. So this thing simply means that sulfur dioxide will be able to escape the reaction vessel or the flask, and hence the mass will decrease. Are you together? Whenever you are forming a gas or reacting two gases, for those gases not to escape the reaction vessel or container, you must have a closed system. Are you together? Since this system is not closed, the gas will be able to escape. That's why there's a decrease in mass. Okay, at which time did the reaction of pure sulfurous acid stop? They're asking me at which time did the graph of pure sulfurous acid start to be flat. The pure solution is the one in bold, no? Okay, where did it start to be flat? Somewhere here. Yes, it started to be flat, no? 6, 6.2, 6.4, 6.6, 6.8, and 7. Okay, that place there is 6.4 seconds. That's 6.4 seconds. So the pure sulfurous acid stopped. The decomposition stopped at 6.4 seconds. Okay, and then 5.3, we are asked to calculate the change in mass of the pure sample. The change in mass of the pure sample change in mass is simply let me write where I have too much space. The change in mass is simply the mass final minus mass initial. The final mass, guys, is there, and that is 116 grams minus 160 grams. So the change is 116 minus 160 is negative 44. This thing simply means that the mass of pure sulfurous acid has decreased by 44 grams. Are you together? For others, you could have done this. You'll still have the same answer, ne? Just take 160 minus 116, and then you'll get your positive 44 grams. You'll still get the same answer, ne? This thing simply means that the change is just 44 grams. The change is just 44 grams. Okay, they want us to find the percentage yield of the impure. Okay, for us to find the percentage yield, we must find the change in mass of the impure first. Okay, it started as 160 there, and that it ended up as 135, because you can see that the parallel lines are between two numbers, which is just 134 and 136. So I can simply say that for me to find the change in mass, I can simply say 160 grams minus 135 grams. What will I get? 160 minus 135, I'll get 25 grams. Are you together? So therefore the percentage yield of the impure substance, do you want the percentage yield? Yes. Let me write it in blue. The percentage yield, please guys, if you are not familiar with what you're doing, calculating the percentage yield, there are videos, guys, that are there. They're just under the topic of stoichiometry. There are 6 videos which are there. You'll find them, but you'll know how to find the percentage purity, percentage yield, determining the limiting reagent, finding the empirical formula. All the stuff is there, guys. Please click on the playlist in the description button. Yeah? Okay, percentage yield is just the change in mass of the impure all over the change in mass of the pure substance. So in this case, we just have 25 all over 44, multiply everything by 100. What do we get? Let me punch my precious calculator. I have 25 over 44, and then I multiply everything by 100. I'll simply get 56.81%. Okay, now I've calculated my percentage yield. Okay, I'm told that 100 grams of sulfur dioxide has now reacted with 50 grams of oxygen according to the following balanced equation. Calculate the number of moles of sulfur dioxide. Okay, the number of moles of sulfur dioxide, the molar mass for sulfur, I know that sulfur, guys, you'll find the molar mass there in the periodic table. Yeah? You'll go to sulfur. This is your relative molar mass. Are we together? sulfur dioxide is SO2. So we have sulfur and oxygen. So for sulfur is 32 and then oxygen is 16. Then let's go and calculate. Sulfur dioxide, sulfur is 32, right? And then oxygen is 16, but we have two oxygens there. So our relative molar mass for sulfur is 32 plus 16 times 2, which is 32. We get 64, right? So for us to find the number of moles of sulfur, the number of moles is simply mass over the molar mass. The mass is 100 grams, molar mass is 64. So 100 divided by 64 grams per mole. What do I get? The number of moles of sulfur dioxide, let me write like this. Number of moles of sulfur dioxide is 1,56 moles. And then for oxygen, please note that the molar mass for oxygen, the relative atomic mass number, is just 16. Oxygen is 16, but we have two of them there. So it's 16 times 2, which is just 32. So the number of moles, it's simply mass over the relative atomic mass number. The mass is 50, and then the molar mass is 32. So what is 50 divided by 32? I still get the same number. Okay, the number of moles of oxygen is simply 1.56 moles as well. Okay, and then I'm being asked, determine which substance is the limiting reactant. Okay, the limiting reactant is the one that will give me a lesser amount of output. Are you together? So in this case, just to be safe, guys, but you can just see this thing according to the ratios, but if you want to be safe, please just do the ratio in proportion. Sulfur dioxide will always give me 2 sulfur trioxide. Are you together? This time around, I don't have 2 sulfur dioxides. I have 1.56 of them. I want to know how much of sulfur trioxide will I form. So I'll just cross multiply. Then 2 times 1.56. I'll get 3.12 is equal to x. No, excuse me. Then 2 times x, I just get 2x. Then I divide both sides by 2. Then x is just 1.56. So this is the amount I will get from sulfur dioxide, the amount of products. Let me see the amount of products I will get from oxygen. Let me write it in blue. From oxygen. Remember that 1 oxygen will always give me 2 sulfur trioxides. If I have 1.56 oxygens, I want to know how much of sulfur trioxide will I be able to form. Just cross multiply. This is 3.12, then x. We can both see that oxygen will give me a huge amount of sulfur trioxide, but sulfur dioxide will give me the smallest amount of sulfur trioxide. So in this case, sulfur trioxide is my limiting reagent. Are you together? So sulfur trioxide is my limiting reagent. Sulfur dioxide is my limiting reagent. Okay, now they want me to calculate the mass of the sulfur trioxide produced. Please, guys, remember that the maximum amount of sulfur trioxide that will be produced will be determined by our limiting reagent. Are you together? So since sulfur dioxide is our limiting reagent, I know that the maximum amount of sulfur trioxide will be this amount of moles. Are you together? Because the progress of the reaction is being determined by sulfur dioxide, which is our limiting reagent. Are you together? So this X here just represents the number of maximum moles which will be formed in this reaction, because we are being limited by sulfur dioxide. Are you together? So the X just represents the number of moles of products, which is sulfur trioxide, that are produced. It's 1.56 moles. Are you together? So now they want me to find the mass that will be produced. Okay, let me just erase here and calculate the mass. I know that number of moles is always mass all over the relative atomic mass number. If my number of moles is 1.56, I don't know what the mass is, but I know that the relative atomic mass number, sulfur is 32, and then oxygen is 16 multiplied by 3, I will get 80. So therefore, for me to find the mass, I'll simply take 80, multiply it with 1.56. 80 multiplied by 1.56. What do I get? 124.8 grams. So the mass of sulfur trioxide which is produced is 124.8 grams. Guys, please stay tuned and wait for more videos. We're just going to focus on the quantitative aspects of chemical change for now, and then we'll obviously move to the other topics. Thanks for your time, guys, and please stay tuned for more videos.